Okay, so in the diagram below, math is a rectangle where GB is 4.6, MH equals 6, and HT equals 15. So I start with these questions by labeling everything they give us, because I want to identify what I know and what I need to know. So GB is what? Well, GB is this right here, this segment. And that segment is the height of this triangle MBA, right? So that's going to be useful to us, and that's 4.6. So we'll label that. MH, where's that? Okay, MH is the side of the rectangle right here. So this is going to be 6, and that's going to be useful as well. Right? They wouldn't give us information, I think, here if it wasn't useful in some way. So if it doesn't seem obvious yet, we write it out. So we can start sorting what will work. Next we have HT, which is this segment right here. So what do they want to know? So HT is 15. They want to know what is the area of polygon MBATH. So I would identify that. That is, oh, excuse me, MBTH. So we outline that. MB, A, right, TH. So it's this polygon right here. It's kind of odd shaped polygon. So shade that in. So to find this area of this shaded shape, and usually with these kind of problems, it's a matter of finding a total area and then subtracting out another area. So here, I like to find the area of this whole rectangle and subtract the triangle, almost to cut this triangle out, because if we cut this triangle out from the rectangle, that's MA from the math rectangle, right, what we have left over is the shaded region. So the area of the rectangle isn't a problem. The challenge here is to find the area of this triangle. And we don't know the length of MG or GA, so we can't use those two segments up here, right? These are not going to be available to us. And also we don't know the length of MB or BA, these hypotenuses of the right triangles. So the way I'm going to go about solving this is to find the area, let's draw a line right here, of this rectangle below, right? We have this piece, or at least split the rectangle to this piece below, and then this other piece above, because what that will allow me to do is find the area of the triangle. Let me show you how. So what I'm going to do is say, I'll call this X. So what's the length of M to X, right? This segment right here. Well, that's 4.6, right? Because it's going to be the same as GB. So MX is also 4.6. So we have this rectangle now. I'll label this. This is 4.6. So this upper rectangle here, I'm going to shade it in. I know I'm certainly messing up this diagram, so it looks kind of sloppy, but sorry about that. So this upper rectangle here, that's going to be 4.6 in height by 15 in width, right? This is 15 right here. So we just calculate that really quick. We have 4.6 times 15, and that's equal to 69. So that's the area of this rectangle right here. But the triangle is half that area, right? If this triangle has the same height as the rectangle we just found, right, it has the height GB, sorry, and the same width, then the triangle is half the rectangle. That's the definition of the area of a triangle. So the triangle is going to be half of 69. So we take 69 and we cut it in half. Okay, well, what's that? So 69 divided by 2 is 34.5. So the area of this triangle is 34.5. Now we're almost done. So this area of this triangle right here, of triangle MBA, is subtracted from the total area of the larger rectangle. So that's the larger rectangle is just 6 by 15, right? And what's that? Well, that's 90. So we take 90, the area of the rectangle, and subtract 34.5, and we get our answer, which is 55.5. That's the area of this rectangle, of this polygon. Sorry. So again, the general approach is to find, in some way, an area and subtract a portion to get this shaded region. That will usually help. In this case, the shaded region is this polygon. So we found the area of the triangle, subtracted it from the larger rectangle, and we were done. All right, thanks.